Hello students, welcome to lecture 8 of polynomials. Today we will start with division of polynomials, that is a remainder theorem. Okay. Now, very simple language if I say that if there is a polynomial p of x which is divided by a polynomial g of x, okay, then there will be a quotient which is q of x. Then we will have a quotient and there will be a remainder also, that is r of x. Okay, like see, if I give you an example, suppose we divide 23 by 5. Let us divide 23 by 5. We will say 5 fours are is 20, we'll get 3. That means here this is the quotient q of x, this is the remainder r of x. Okay, this is nothing but g of x and this is the polynomial p of x. Okay, this is just to make you understand. Correct? Now, what is 23 here? That is p of x. And what is p of x? P of x is nothing but a dividend. So we can say p of x is dividend. Okay, now g of x is nothing but the divisor. Divisor means it is a number which divides the given number. Okay, so g of x is the divisor. Here q of x is nothing but the quotient that we already know, and r of x is the remainder. Correct? Now we will say that what is dividend? Dividend is nothing but a divisor into the quotient plus the remainder. When we do this, we should get the dividend. Now, let us take this example only. The dividend is 23. Then the divisor 5 should be multiplied by 4. Because 5 is the divisor, 4 is the quotient, and 3 is the remainder which should be added. So, we will get 20 plus 3, that is equal to 23. Okay. So, this way we will do the division of a polynomial also. This was a simple number. The same thing you have to do in the division of the polynomial. The only thing is आपको px, qx, qx, rx, these things which comes, you think it is very hard, but it is not so. Okay. Now only one thing you should remember, that the degree of rx, that is rx is also a polynomial r of x. The degree of this r of x means remainder is always less than the degree of the divisor. Okay, it is always less, it should be always less than the degree of g of x, that is the divisor. Correct? The degree of remainder r of x is always less than the degree of g of x. You know degree, the polynomial is given and the exponent, the highest exponent is the degree of the polynomial. Okay, so the remainder's degree should be less than the divisor's degree. That means I can say this 23. Okay, it is the divisor. No, what is 23 is the dividend. What is the divisor? 5. The remainder is 3. Then 3 should be less than 5. ऐसे बोलते हैं वो. That is, the degree of the remainder should be less than the degree of the divisor. Okay, if the divisor is having 1 degree, suppose the divisor is having 1 degree, then the degree of remainder will be 0. Then the degree of remainder will be 0. Okay, that is, the remainder will be a constant. So the remainder will be a constant. There will be a number. You will get a number because we know that if I take 5, then x raised to 0. Degree is 0, but we can say that it is 5 into 1 and 5. So it is a constant. So that means that the remainder will be a constant. You should keep in mind this much, that if the divisor is of 1 degree, okay, then the remainder will be 0. Degree of the remainder, okay, will be 0. That is, the remainder will be a constant. Got it? Again, I will explain it once more, that if p of x is a polynomial which is divided by a polynomial g of x, that is, if 23 is divided by 5, then the q of x will be the quotient according to the above example, which is 4. This is nothing but the quotient, and of r of x will be the remainder, that is 3, which we got in the above example. Okay, and we can say that the dividend, that is p of x, is nothing but the divisor g of x into the quotient q of x plus the remainder. This you should remember. And other thing is, this degree should always be less than this degree, that is, degree of r of x should be less than degree of g of x. And the other thing is that if degree of g of x is 1, then the degree of r of x, okay, not the remainder, but the degree of r of x will be 0. That is, the remainder will be a constant. Got it? This is nothing but division of a polynomial. This same theory we will do by understanding an example, so we'll be able to understand. Okay, I will end my lecture over here. In next lecture we will take an example. Thank you very much.